to solve. That's our first method of the day. Factoring to solve means you're going to use what's called the zero product law. We actually used it a couple times last unit, like on that bonus question on your test, where you had to factor a quadratic, then you set each factor equal to 0. The zero product law technically means that if you have a product, so product means multiplying. So if two things multiply together, like A times B, to equal 0, one or both of those terms that are being multiplied has to equal 0. That's the only way that a solution to a product can be 0. Okay, so the zero product law helps us solve quadratics because when we solve a quadratic, that means where does the quadratic equal 0? We're going to talk about what we find in a minute there. But if you have factored form, you have the first factor, x minus 7, times another factor, x plus 2. Since they're being multiplied, if they equal 0, we want to know where would each one of them be equal to 0. So you guys know how to do this. We did this last week. You take each factor, x minus 7, and you set it equal to 0. And you set x plus 2 equal to 0. That one's already in factored form for you, just to kind of illustrate what's going to happen. That should be pretty easy. If you add 7 to both sides, what's one solution to this? X equals 7. So x is one solution, 7. Then the other one you would subtract 2. And the other solution is negative 2. Okay? So we've been doing the zero product law, or we've used it for a couple things. You did it in Algebra 1. That one was easy. I gave you factored form. You do have to remember how to factor, though. So how would you start 6x squared minus 150? We always want it equal to 0. When I'm solving a quadratic, the equals has to be 0. What do you always do first when you factor? Is there a GCF here? There's actually bigger than 3. 6. 6 goes into both. So you divide 6 out. You'll get 6 times x squared minus 25. Okay. So I have that. I factored the GCF. Now I look again. Can I factor that anymore? How? Difference of squares. All right, so this would be 6 times square root of x squared is x. What's the square root of 25? 5. So I have x minus 5 times x plus 5. Still equal to 0. Now, when I use the zero product law here, I take each factor that has an x in it. Right? So I'll take x plus 5, set it equal to 0, and x minus 5. Does anyone know why I don't do 6 equals 0? It doesn't have an x, and then is that a true statement? Does 6 equal 0? No, so it's not even true. That 6 does not change the solutions. It's just a factor. So we'll talk next semester about this 6. It actually just makes your parabola taller or wider, but it doesn't actually affect the x-intercepts. So when you solve these, what two solutions do you get? 5 and negative 5. All right, good so far on that one? So we should still remember how to do GCF, how to do difference of squares, and foresee how to solve this. So I have 4x squared equals negative 16x minus 7. I can't do anything with that yet. What has to be true if I'm going to use a zero product law? It has to be equal to 0. So I want to move, I'm going to keep the 4x squared where it is because it's a positive 4x squared, so it's easier to factor. Let's move these other terms to the left. So you're going to add 16x and add 7 to both sides. So you'll get 4x squared plus 16x plus 7 equals 0. Now you have a trinomial, and you can factor using what method? Split the middle. All right, so we have to remember that first term times the last term is 28. I need two numbers that multiply to 28 and add to 16. 2 and 14. Yep. All right. I'm going to go down a little bit here so I have some more room. Great. So if you forget how to do split the middle, you can do guess and check too if that works for you. But you take the first term, 4x squared, plus 2x, plus 14x, what you decided to split the middle with, and then plus 7 on the end. now you group the first two terms together, and you group the last two terms. And from each group, you find a GCF. 2x in the first one. So 2x times what's left when you pull a 2x out? No, just 2x plus 1. Pulling one x out drops that exponent. And then what's the GCF of the second term? 7. So plus 7, and you'll have 2x plus 1, which is a good thing because you want your two parentheses, your quantities, to be the same, which they are. So what's the final factored form? Yep, 2x plus 7, 2x plus 1. It does not matter the order you write them in. Equals 0, you're right. But we now set each of those equal to 0 to use the zero product law. And you have to solve each of those little mini linear equations. On the left one, you'll subtract 7 and divide by 2. So let's go ahead and solve those. And then you can check up here and see if you get the same two answers. You'll get fractions. You can leave them as a fraction. Where's a decimal? What fractions are? Do you remember doing? Yes, it's just time consuming. Do you remember doing that though? Yeah. Okay. That's why I only did 3 little problems here, because I didn't feel like we needed a whole day to review solve by factoring. But you should know how to do any factoring method. Split the middle, trinomials, difference of squares, GCF. You won't have to do any cubes. We'll go back to factoring using the SOAP method at the end of the school year. Yeah, we have a couple months, so we have to do that one again. Well, I guess on your exam. Other than your exam, you don't have to do it. Same opposite always. All right, we good here? Now you need your calculators. We are going to shift gears now. That's solving a quadratic by factoring. Sometimes that's a good method. It's not a bad method to be able to solve by factoring. But it's always a little nice when you can just let your calculator do the work for you. So when we solve by factoring, it says the values of x that solve a quadratic equation are called solutions. And that's ultimately what we're looking. What are the solutions of the quadratic? As we review in solving by factoring, look, I can find the solutions one way by factoring. These solutions have other names. They can be called the roots or the zeros of a quadratic. Because the reason they get those names, roots or zeros, is because when you plug those values back into the equation, they cause it to equal 0. So we found the values of x that make the equation equal 0. That's what we solved for. Now we want to know what happens when we craft these quadratics. So we're going to look at this example. We'll start with x squared minus 2x minus 3. First they want us to factor to solve, because we didn't do this is a really simple factoring one here. But remember, when you factor a trinomial where the leading coefficient is 1, right, it's just plain old x squared, it's a little faster than split the middle. You think, okay, I need two numbers that multiply to negative 3 and add to negative 2. Negative 2? Negative 3 and 1. Yeah. Right idea. Wrong number. Negative 3 and 1. Well, what's the shortcut here? Instead of doing split the middle, how do I write that factor form really fast? Remember how you can just jump right to your parentheses? What would be in your parentheses? X minus 3, x plus 1. So if there's no leading coefficient other than 1, you can jump right to your factored form. Well, then when I solve this, if I used each of these factors and set them equal to 0, what would be the solutions here? X equals 3 and negative 1. Okay, that's easy. That threw another factoring review problem for us. Now let's use our graphing calculator. Right? And I need to turn mine back on because when the internet was out this morning, it was causing all kinds of problems with everything. But why don't we take a second and type that equation into the y equals on your calculator. So we'll type in here x squared minus 2x plus 3. table, graph. Just go, oh, I must have typed that wrong. X squared minus 3. I did the wrong number. That would do it. Minus 3. Okay, now when I graph it, we should get a parabola that looks like this. Okay, now, what is it asking us to do? It is asking us to use your graphing calculator to draw the graph of the function on this grid. All right, so I want you to take a minute and look at the table. You don't have to write it. I know there's space to write it on your paper, but go to your table here. I want you to plot as many points as possible that will fit on that grid. Did you use a negative sign instead of a minus sign?
Probably.
I'm going to pause this for a minute. We should have a graph like this on our paper. What do you notice about the x-intercepts of this graph? Where are they? Where's the x-intercepts of the graph you made? X is at negative 1 and 3. What is the connection to what we did with factoring? That's what the x equaled. So the x-intercepts were the solutions.
So can you do either way and get the same?
Yes, so we're actually going to do a lot of ways this unit. We're going to factor, we're going to graph, quadratic formula, complete the square. We're going to have 4 different ways to find the solutions. Now, they're not always going to work, and they're not always going to be helpful. But these are the 2 easiest ways. So let's flip our paper over, and let's talk a little bit more about graphing. We're only going to make one more actual graph picture, and then we'll just use our calculator to speed up the process. So here's the takeaway. The x locations of any function where the output's equal to 0 is called the 0 of the function, which is the x-intercept. So the solutions are always where the graph crosses the x-axis. So now let's take our calculator again. I want you to graph x squared plus 5x plus 3 on your calculator, and then graph it. Okay? So everyone should be hopefully back to Zoom 6 now, or standard window. X squared plus 5x plus 3. Hit graph. And I want you to take a minute, and then you should have a picture that looks like this. Graph that onto your paper. Numbers. No. So we should be able to say that between what 2 numbers is the left x-intercept? It's easier to see up here, I think. Yeah, between -4 and -5. So that's one x-intercept, so we'll put that here. -4 and -5. And where's the other x-intercept in between? Yeah, it wasn't very neat. Sorry. -1 and 0. I was trying to save some space. I'll make it a little neat. I'll just use the word and. How about that? -4 and -5. -1 and 0. So we know we're going to have a decimal x-intercept, but we don't know what they are yet. So let's decide, can we solve this by factoring? Because if I can factor it, it doesn't really matter if I can see the nice ones on my graph. So let's see. If this is a 1, I need to find 2 numbers that multiply to 3 and add to 5. No, 1 and 3 are my only combination, so does this guy factor? No. So unfortunately, factoring doesn't work here. So we need to use our fancy calculators that our parents paid a lot of money for to find our x-intercepts, or that you paid a lot of money for, either way. Do you guys remember how to find x-intercepts on your calculator?
Yes.
Yes? Second trace?
What is second trace?
Second trace? Which one do you think you're going to choose?
Intersect.
No, that's intersect. That's if you have 2 lines, where do they cross?
It's value.
No?
0.
0. Remember we just said x-intercepts are also called 0. No, this one's different. So I want you to pay attention here. Now, if you have a TI Inspire, yours is easier than this. I'll show you in a minute. If you have a TI 83 or 84, I want you to pay attention. You should see a flashing cursor, right? Somewhere on your screen. On the bottom, it says left bound with a question mark. No assumption. So you're going to take that cursor and you're going to take it to the left of the x-intercept. So if I do this x-intercept right here, I want that cursor to be a little bit to the left, which means below. Where that one? Okay, so I'm going to make this go a little bit below. Doesn't have to be a lot, just a little. Because it's technically to the left of that. And you're going to hit enter the first time. Now, some of them will make a line. Now you're going to go to the right, which means you use the right arrow. A little bit to the right of that X-intercept, which would be on the other side of the X-axis. You hit enter your second time, and then your third time is guess. When you hit enter, you should get negative 0.697. 224. Yep. That is where your X-intercept is. So we'll estimate. We'll do negative 0.697. Okay, is that between negative 1 and 0? Like we said. Good, so that's one X-intercept. Now we need to do the second one, which we should say should be between negative 4 and negative 5. So we do the same thing again. Second trace, 0, number 2. Now our cursor this time to be on the left is going to be a little above the X-axis, right? It's just, you're going to arrow to the left until you are past the X-axis. Go over there. Right, to arrow left, I'm a little bit past, and I hit enter. That was one enter. I use the right key to go a little bit past it on the other side. Enter again, and guess for a third time. Negative 4.303. Make sure you're doing this on your calculator if you're not doing the right thing. Now, if your calculator gives you an error, it probably means, like, if you get an error that says bound error when you do your calculator, that means that you didn't go on opposite sides of the X-axis. All right, like both of them are below. So we'll do a couple more here, and then I'll help inspire folks find yours because yours is super fast. Okay? So, big idea before we do a little bit more here. Graphing a function to find its zeros, roots, X-intercepts, solutions, whatever you want to call them, is helpful when you can't factor. If you can factor a quadratic, you can always find the X-intercepts, but that last one didn't factor, so the only way to find the X-intercepts is to graph it. So let's decide here. We're going to decide if we can factor something based on its X-intercepts. So I want you to type into your calculator, negative 3x squared minus 14x plus 5. I want you to decide what are the roots. So I want you to graph this. I'll come around and help you. As your, I was, okay. Okay, so we have these answers. Now, are those roots rational or irrational numbers?
Irrational.
They're irrational. What is 0.3 repeating?
1/3.
1/3. These are both rational answers. So because they got rational roots, do you think that you could factor that quadratic?
Yes.
Yes. If you get rational roots, you should be able to, or you should, for 100% be able to factor the quadratic. So if I have the quadratic negative 3x squared minus 14x plus 5, how would you factor it to solve it? Split the middle. All right, we're going to pause. We're going to come back to that one. But you would do split the middle here. I want to be able to move on to get to the last problem. Okay? So now I have example 5. I want you to take a second, and I want you to graph 3x squared plus 3x minus 4 in your calculator. I want you to find the roots by graphing on your calculator and round to 3 decimal places. I'm going to give you like 2 minutes here. So, if I have these two X-intercepts, are those rational or irrational numbers? They're irrational, so do you think you can factor this quadratic? No. Why not? Because it's irrational, and when I factor things, I can only get rational roots. Now, let's talk about the bottom here. We'll get more practice doing graphing in a minute. I'm going to give you the graph here. What are the roots of this graph in example 6? Negative 3 and positive 2. Based on the nature of those roots, could you factor whatever the equation of the quadratic is?
Probably.
Yes. Irrational, right? So because these are rational, then yeah, you could factor this if I asked you to, if I gave you the equation. So we're going to come up with the equation for that quadratic only by knowing the X-intercepts. So here's what I want to point you at before we figure out how to do this. when I come back up above here, let's see, let's do this one at the top. Very top of your page, or the back front of your notes. If I have the x-intercepts of -1 and 3, what's your notice about the factored form and those x-intercepts that I have? They're the opposites, right? We had x equals +3, which came from the factor of x minus 3, and x equals -1, which came from the factor of x plus 1. So that's actually how you come up with the equation. You take the opposite of the factor. So if I have x minus 3, what would be the factor it comes from? X plus 3. If I have x equals 2, what factor does that come from? X minus 2. Well, that's the factored form of the equation. How could I come up with the standard form? ax squared plus bx plus c. FOIL. Distribute. So let's FOIL here. Well, x squared minus 2x plus 3x. Guys, we're not done. Don't press up yet. Alright, how does that combine together? X squared plus x minus 6. That is the equation of that parabola. Okay, so here's what I need you to do tonight.